Let's look at polynomial division. We will start by looking at the fraction 6x cubed minus 16x squared plus 17x minus 6 over 3x minus 2. Often when we try to simplify fractions, we first try to find a factor that will go into both the numerator and the denominator. But in this case, factoring would not be too easy. So what we really want to find out is whether 3x minus 2 will go into the numerator of our fraction. So we're going to do long division. And long division with polynomials is very much like doing long division with whole numbers. We will start off by writing the fraction in long division form. We're going to look at the first term of the divisor, which would be 3x. And we're going to divide that into the first term of the dividend, which is 6x to the third. In this case, when we divide, we get 2x squared. Our next step is to multiply 2x squared times both numbers in the divisor. 2x squared times 3x is 6x cubed. And 2x squared times negative 2 is negative 4x squared. Basically, all we're doing is using the distributive property. After that, we're going to subtract, giving us negative 12x squared. We need to bring down the next term, and we'll be ready to repeat the process. You may want to pause the video and take some time to make sure you understood the steps we just followed. When you think you've got it, go ahead and unpause the video. The next thing to do would be to divide negative 12x squared by 3x, and we get negative 4x. Negative 4x times 3x minus 2 is negative 12x squared plus 8x. Now we will subtract, getting 9x. Next we'll bring down the negative 6. 9x divided by 3x is 3. And 3 times 3x minus 2 is 9x minus 6. When we subtract these, we get 0, and the problem is done. That is to say, the fraction reduces to 2x squared minus 4x plus 3. If we want to check our work, we'd simply multiply our answer by 3x minus 2, and we should get the numerator of our fraction. I am using the multiplication array to multiply the polynomials, and as you can see, the problem checks. Now that you have the basic idea of how to do long division with polynomials, let's look at another example and focus on some of the finer points. I'm going to start with the problem 3x to the third minus 2x plus 5 divided by x plus 1. The first thing I want you to notice is that I do not have an x squared term. And that will be relevant because when I look to see how many times x goes into 3x to the third, well, that would be 3x squared. Because there's no x squared term, I don't have a place to line that number up in the column. So therefore, what I'm going to do is actually put a term in there. And since I don't want it to have any value, it'll be 0 times x squared. Now I've got all the terms, I can proceed like usual. So x goes into 3x cubed, 3x squared times 3x squared times x plus 1 is 3x to the third plus 3x squared. I'm going to subtract those, getting negative 3x squared, and bring down my negative 2x. X goes into negative 3x squared. Well, that would be negative 3x. So negative 3x times x plus 1 is negative 3x squared minus 3x. And when I subtract those, I get x. I'm going to bring down my 5. X goes in x one time. 1 times 1x plus 1 is 1x plus 1. When I subtract those, I get a remainder of 4. So what do I do with my remainder? Well, just like regular division, when we have a remainder, we often write that as a fraction. So I'm going to add to my answer here 4, my remainder, over the number I was dividing by, which in this case was x plus 1. So my final answer is 3x squared minus 3x plus 1 plus 4 over x plus 1. So we saw two things here. First is when I'm missing a term in the number I'm dividing into, I'm going to need a placeholder, which in this case was 0x squared. And the second is that when we have a remainder, we'll be writing that as a fraction. So now I need to check this, and I want to do it differently this time. I want to look at a different way to say, does this answer make sense? So let's think about what we just said. We said that our division problem, x plus 1 divided into 3x to the third minus 2x plus 5, is the same as or is equal to 3x squared minus 3x plus 1 plus 4 over x plus 1.
we don't know what the value of x is. In fact, all values of x, except for ones that may make the denominator of my fraction 0, should be a possible answer. So one way to check this is to substitute a value in for x and make sure that both sides of the equation are still equal. Because I like my math simple, I'm going to pick the value 10. So I get 10 plus 1 divided into 3 times 10 to the third minus 2 times 10 plus 5. And on the other side of my equation, I would have 3 times 10 to the second minus 3 times 10 plus 1 plus 4 over 10 plus 1. So remembering our order of operations, let's simplify that. So 10 plus 1 is 11. I'm going to divide that into 3 times 10 to the third, well that's 3,000, minus 2 times 10, which is 20. When I subtract 20, I get 2,980. When I add 5 to that, I get 2,985. And on the other side, I got 3 times 10 squared, which is 300, minus 3 times 10, which is 30, plus 1, plus 4 over 11. Well, 300 minus 30 is 270, plus 1 is 271, and 4/11. So let's go ahead and do our division. 11 goes into 29 2 times. I subtract, I get 7. I bring down my 8. 7 times 11 is 77. Subtract, I get 1. Bring down my 5. 1 times 11 is 11. And then subtract, I get 4. So my remainder would be written as 4 over 11. So on both sides of the equation, we see that we have 271 and 4/11. Therefore, our problem checks.